Hi guys, maayong adlaw. Welcome to my channel. For this video, I will be presenting to you about compositions with functions. This topic is in relation to the topic that I had presented in the previous video about operations with functions. So to start, the lesson objective, at the end of this video, you should be able to solve for the composition of functions. The prerequisite skills for this topic are operations with polynomials, factoring, and evaluating functions. So let's start. If we are given the functions f and g, the composition of the functions f and g is denoted by the notation f circle g, which is the composition of the functions f and g. And this notation is defined by this equation, wherein the input x or the x is in the domain of g and the g of x is in the domain of f. To understand more about this notation, let's proceed directly to the examples. Given the set of functions, the g of x, the p of x, the h of x, the q of x, f of x, and the r of x. For example 1, we are told to find the composition of the functions q and h of x. So our domain is not being specified here. So we are not going to evaluate the function because we do not have the value for domain here. So how do we write this notation? We go back to the first function in this notation. The first function here is q, the function q. And the function q is denoted by the function 4x minus 5. So the first things first is to write the first function, which is 4x minus 5. In this function, we have here the variable x. We need to substitute the function h to x here. So meaning, we have to change x with x plus 4. So the resulting function would be, we copy 4, instead of writing x, we change that with x plus 4. Then we simply copy minus 5. Then we simplify by distributing 4 to the terms inside the parentheses. So we will have 4 times x and 4 times 4. So that gives us 4 times x is 4x, 4 times 4 is 16. Then we copy minus 5. 16 and 5 are constant, so we can subtract. So the resulting function will be 4x plus 11. So since our domain is not being specified, so this is now the final answer. Let's proceed to the second example. We are given the same set of functions and we are to find the composition of the functions g and h. Our g is defined by the function 2 plus x squared and our h is defined by x plus 4. So again, we write first the function g, which is 2 plus x squared. And from this function, we need to substitute the x with the function h, which is x plus 4. So the resulting function would be 2 plus, instead of writing x, we change that with the function h, which is x plus 4, and the exponent 2. Afterwards, as you can see, this is the square of a binomial. So x plus 4 quantity squared. We need to expand the square of a binomial. So we just simply copy 2 and we square x. The square of x is x squared and twice the product of the first and the second term. So x times 4 is 4x times 2, that is 8x. Then the square of 4 is 16. Then combine like terms. 2 plus 16 is 18. So the resulting function would be x squared plus 8x plus 18. Then third example, the same set of function and we are to find the composition of the functions p and f. So the first function p is defined by the function 3x. Then f is defined by the function 2 minus x squared over 5. So instead of writing x here, we change that with the function f, which is 2 minus x squared over 5. Then we distribute 3 to the numerator, so that gives us 3 times 2 is 6, and 3 times negative x squared is 3x squared. Then this is assumed to have denominator 1, so 1 times 5 is 5. Since our domain is being specified as 1, so we need to substitute the domain x, the domain 1 to this function. So the resulting value would be x 6 minus 3 times the value of the domain, which is 1, then quantity squared. We copy over 5. Then the square of 1 is 1. 1 squared is 1 times 3 is 3. So we will have 6 minus 3 is 3. So that is 3 over 5. Let's proceed to the next example. We are to find the composition of the functions r and p, and we need to evaluate the function using the domain negative 6. So our r is x over x plus 1, so x over x plus 1, and our p is 3x. So instead of writing x here, we change that with 3x, and our x here is changed to 3x. Then afterwards, we need to substitute the domain, which is 6. So we have 3 times negative 6 over 3 times negative 6 plus 1. So 3 times negative 6 is negative 18. The same also with the denominator. 3 times negative 6 is negative 18 plus 1. We copy negative 18 in the numerator and we perform the operation in the denominator. So negative 18 plus 1 is negative 17. Now since both the numerator and the denominator are all negative, so the final answer would be positive 18 over 17. Let's proceed to the last example. Still you are given the set of functions and we are to find the composition of the functions q and g. Then we need to evaluate using the domain negative 2. The function q again is 4x minus 5 and the function g is x plus x squared. So write the first function, which is 4x minus 5, and the g is 2 plus x squared. So we need to change this x with 2 plus x squared. So we copy 4. The x is changed to the function g, which is 2 plus x squared, and we copy minus 5. Then we need to distribute 4 to the terms inside the parentheses, so that gives us 4 times 2 is 8, and 4 times x squared is 4x squared, and we copy minus 5. Since 8 and 5 are constants, so we can combine 8 minus 5 and we just simply copy 4x squared. 4x squared, then 8 minus 5 is 3. Then afterwards, we need to evaluate the function using the domain negative 2. So substitute this value to x here, so that gives us 4, we copy 4. Then x is negative 2, quantity squared, we copy positive 3. The square of negative 2 is positive 4. So this is 4, we copy 4, and the square of negative 2 is positive 4. We copy plus 3. 4 plus 4 is 16, plus 3 is 19. So the final answer is 19. So that's it. Soon I will be presenting to you more challenging examples about these different operations with functions. So I will be presenting examples about addition, subtraction, multiplication, division, and composition of functions. But before I go, I wanted to give you this practice exercise. So you are given the p x squared, the q is x minus 3, and the r of x is 2x minus 1. And solve for these compositions. So for now, I will leave this with you. The essence of mathematics is not to make things complicated, but to make complicated things simple. This is by S. Goodard. Thank you and God bless.